Apex is powerful because it runs without restrictions by default. It can see and modify anything in your org. That's useful for batch jobs and integrations. But the moment a regular user triggers your Apex from a Lightning component or a community page, that same unlimited power becomes a security hole. This tutorial walks you through every mechanism Salesforce gives you to control that power precisely. With real code, you can adapt immediately. Here's the core problem. When Apex executes, the platform doesn't automatically look at who triggered it and restrict what it can do. It runs as if a system administrator wrote every query. If a standard user clicks a button that calls your Apex class, and that class has no security enforcement, they can read records they've never been granted access to, accounts from other territories, sensitive financial data, anything. This isn't a theoretical risk. It happens in production orgs constantly. The misconception is that profiles and permission sets handle this automatically. They do for standard UI operations. Salesforce enforces FLS when a user edits a record through a page layout. But Apex sits below that layer. When your code runs a SOQL query, the platform doesn't check the running user's permissions unless you explicitly tell it to. This surprises developers coming from other frameworks where security is enforced by default at every layer. The first tool is the with sharing keyword. You write it right after the access modifier on your class declaration, public with sharing class account service. What this does is tell Apex to apply the current user's sharing rules when running SOQL inside that class. If a user can't see an account record because no sharing rule gives them access, a query inside this class won't return it. Think of sharing rules as the list of records a user is allowed to see. With sharing makes Apex respect that list. Without sharing is the opposite declaration. A class marked without sharing ignores the running user's sharing model completely and queries every record in the org. You write it when you genuinely need that access. A nightly batch job that consolidates billing data across all accounts. An integration that syncs records regardless of who owns them, or an admin tool. The key rule: never expose a without sharing method directly to a user-facing controller. It must only be called from system context code. Inherited sharing is the smart middle option for utility and service classes. When a class is declared inherited sharing, it adopts the security context of whatever called it. If a with sharing controller calls your inherited sharing service, the service enforces sharing. If a without sharing batch class calls the same service, it doesn't. The syntax is public inherited sharing class record fetcher. Use this for classes that should be reusable across both contexts. The security decision belongs to the caller, not the utility. Here's the trap that catches experienced developers. A class with no sharing keyword at all doesn't inherit anything. It runs in system mode for record visibility. This looks like inherited sharing, but behaves completely differently. If you write public class lead service with no keyword, every query inside runs without restriction. If a Lightning component calls that class, any user can see every lead in the org. The fix is always to declare a keyword explicitly. For new user-facing classes, use with sharing. For reusable utilities, use inherited sharing. In API version 50.0, Salesforce introduced a more powerful mechanism, the with user_mode clause directly in your SOQL query. The syntax is select ID, name from account with user_mode. This single clause enforces three things at once. The user's sharing rules for row visibility, field level security, so fields the user can't read are excluded, and object level CRUD, so if the user can't query the object at all, the query throws an exception. That's more than with sharing on the class does by itself. With system_mode is the inverse. You add it to a specific query to explicitly bypass all three checks for that query, even inside a with sharing class. The use case is narrow but real. You have one query in an otherwise secure class that needs to read data the user can't normally see, like configuration records managed by admins, or a cross-object lookup to a metadata table. The syntax is identical. Select ID, feature flag _ C from or config _C with system_mode. Use it surgically, one query at a time, not as a class-wide setting. You can mix user_mode and system_mode in the same class, which is a clean pattern for dashboards and controllers that serve both user data and system configuration. The user-facing query uses with user_mode. It enforces sharing and FLS. The configuration query uses with system_mode. It reads admin-managed records the user has no direct access to. Both are in a with sharing class, so the intent is documented at the class level. The query level clause overrides as needed. Dynamic SOQL through database.query-with-binds supports the same access control through the access level enum, available from API version 57.0. Instead of hard-coding the query string with user_mode clause, you pass access level.user_mode as the third argument. The syntax looks like this: database.query-with-binds, SOQL string, binds map, access level.user_mode. This is the correct approach for dynamic queries built at runtime. You get the same three-layer enforcement as the inline clause. Always use query with binds over string concatenation to prevent SOQL injection. For code targeting API versions below 50.0, or when you need to check permissions before DML rather than on a query, you use schema.describe field result methods manually. The pattern is, get the field describe, then check the appropriate method. For reading, that is accessible. For inserting, that is creatable. For updating, is updatable. You access a field's describe through schema.subject_type, account.fields, phone.getDescribe. If the check fails, throw a system.noAccess exception or an handled exception with a user-readable message. This is verbose but explicit. Security.stripInaccessible automates the manual field checking approach. Instead of checking each field one by one, you run your query, then pass the results and an access type to stripInaccessible. It returns an subject_access_decision object. Call.getRecords on that to get the cleaned list with unauthorized fields removed. The four access type values map to DML operations: readable, creatable, updatable, and upsertable. Use readable before displaying data, updatable before update DML, creatable before insert. The method also returns .getRemoved fields, so you can log what was stripped. CRUD enforcement is separate from FLS. FLS governs whether a user can access a specific field. CRUD governs whether a user can perform an operation on the entire object, query it, create records, update them, or delete them. A user might have full field access to opportunity, but no permission to create new records. You check this through schema.subject_type. Opportunity.is creatable, is updatable, is deletable, is queryable. Always check CRUD before DML in user-facing code. A clean pattern is a reusable guard class with static assert methods that throw no access exception if the check fails. The most common testing mistake is writing security tests that run as a system administrator. Admins bypass most FLS checks, so your tests pass even when the enforcement code is broken. Proper security testing requires creating a test user with a restricted profile, typically standard user, using system.runAs. The test then calls your method as that restricted user and verifies either that access was correctly granted for records they should see, or that an exception was thrown when they attempted an operation they don't have permission for. One test per permission scenario. Here's what a fully secured user-facing class looks like. Declare with sharing at the class level. Before any DML, check object CRUD with schema.subject_type, account.is creatable. In your SOQL, add with user_mode to enforce sharing, FLS, and CRUD at query time. Before insert or update DML, run security.stripInaccessible with the appropriate access type. The CRUD check before the query is technically redundant when using user_mode, but it lets you throw a friendly or a handled exception with a readable message before the query fires. Better UX than a raw exception. Start your security audit by searching every Apex class in your org for classes with no sharing keyword. A class that has public class or private class with no sharing modifier is running in system mode for record visibility. Flag each one and add a keyword based on intent. With sharing for user-facing code, without sharing for documented system code, inherited sharing for utilities. This is a one-line change per class that closes the most common exposure vector in Salesforce development. Next, go through user-facing SOQL and add with user_mode to every query that returns data for a user interaction. This applies to Apex called from Lightning components, Visualforce controllers, Experience Cloud pages, and anything user-triggered. The change is minimal. You're adding 4 words to a query, but it activates FLS and CRUD enforcement that with sharing alone doesn't provide. For dynamic SOQL, switch to database.query-with-binds with access level.user_mode. Run your test suite with a restricted user afterward to verify the enforcement is working. The final layer is DML protection. Before any insert, update, or upsert in user-facing code, call Security.stripInaccessible with a matching access type. For inserts, access type.creatable. For updates, access type.updatable. Use the cleaned records from decision.getRecords for the actual DML. Combined with the class keyword and with user_mode on reads, this completes the three-layer defense. Any user-facing class that touches data should have all three: the class declaration, query-level enforcement, and a DML safety net. The full article at Real Syllabus goes deeper. It includes a complete production-ready account manager class that combines every layer, a test class skeleton showing how to verify enforcement against a restricted user, and a decision guide for every scenario. New classes, shared utilities, batch jobs, and legacy code below API v50. If you're building anything user-facing in Apex, that decision guide alone is worth the read. Full link at realsyllabus.com.